Hello students, in the last lecture we talked about the canonical transformation and also we talk about the condition under which the given transformation will be canonical. So today we will discuss the example how to show the transformation will be the canonical one. What is given over here you can check the statement is given. You have to show that transformation. This is the transformation. I call this is equation 1 is the canonical transformation. So as you can see here, t is not involved in the transformation. So that means t is fixed, you can consider, or the transformation. So as you know, the condition under which the transformation is canonical. So this was the condition actually. Okay. Summation pi tilde delta qi tilde minus h tilde delta t is equal to c times of summation pi delta qi minus h delta t minus of delta f. That means there exists some constant c and there exists some genetic function f such that this can be written as c times of this summation minus of delta f. Right? Here summation I is vary from 1 to n, right? You can write down. Wherever summation is there, this is I equal to 1 to n. So since t is fixed over here, see t is not involved, that means t is fixed over here. If t is fixed, so that means delta of t will be 0. So this part will not be over here. Okay. If this part is not over here, that equation will be this one. Okay. So that means you have to show that pi tilde delta qi tilde minus c times of pi delta qi is equal to minus of delta f. Or we consider some constant for c equal to 1. So that means for c equal to 1, you have to show that summation pi tilde delta qi tilde minus summation pi delta qi I equal to 1 to n is equal to minus of delta f. Right? So that thing you have to prove that to show the given transformation is canonical. Or since in the transformation there are only the two equations, okay, q tilde and p tilde. So that means we will not run the summation, we will write down only for the p and q. So there is not so many equations, there are only the one. So you can say that will be p tilde into delta of q tilde minus of p delta q is equal to minus of delta of f. Okay, this thing you have to show. So that means you have to show that if you find out p tilde into delta qi tilde minus of p into delta q, that will be equal to exact derivative of some f, some function, okay, of the same variable t qi pi, right? So I consider the LHS over here. That means p tilde delta q tilde minus of p delta q I consider. So what is the value of q tilde? I place over here. Firstly I place the value of q tilde. So what is the value of q tilde? You can check, this is root 2q into cos p. So I place it over there, root 2q into cos p. So I just place the value, okay, and remaining is h t. Now p tilde, you apply that and the product rule will be applied. You can see that it will be root 2. So what will be the derivative of root q? That will be 1 by 2 root q into delta of q and cos p as it is. Plus now root 2q is as it is, derivative of cos p. Cos p derivative will be minus of sin p into delta of p. That will be there. And the remaining will be as it is. Okay. When you solve this one, it will be this one, cos p delta q minus 2q sin p delta p minus p delta q. Alright. Now you place the value of p tilde. So it is given there. There is given that p tilde was root 2q but sin p. Okay. So I place the value over here. When I place the value, you just get multiply inside the bracket. You will get sin p cos p delta q minus 2q sin square p delta p minus p delta q. Okay. So you can rewrite this, multiply and divide by 2. So you can 2 sin p cos p sin 2p and 1 by 2 sin 2p delta q minus p delta q minus of this is there. Over there in these two terms, delta q is common. You can write it as 1 by 2 sin 2p minus p into delta q plus that term minus 2q into sin square p into delta p I have written. Okay. Now you can check that this terms is in the form of this one. You have already studied that m dx plus n dy. Okay. So that will be the exact derivative of some function. If that means that will be the exact derivative of some function when the partial derivative of this m with respect to this y, okay, and partial derivative of this n with respect to this x is equal, then this will be equal to some exact derivative of some function. Okay. So similarly here, what is here? This is some m into delta q plus n into delta p. So you say that partial derivative of m with respect to p and partial derivative of n with respect to q. Okay. If that will be equal, then that will be the exact differential of some function. Okay. So that means you will say that is partial derivative of this with respect to p, that should be equal to partial derivative of this with respect to q. Okay. That should be equal. So I check that. पहले ये चेक कर देते पार्शियल डेरिवेटिव क्या आता है निकल के और फिर ये चेक कर लेंगे. ओके. सो आई चेक वन बाय वन. Now when you take the partial derivative of this thing with respect to p, it will be 1 by 2 cos 2p into 2 minus of 1. 2 will be cancelled out and you say that cos 2p minus 1. Right? And when you find out this value, you will say that partial derivative of minus 2q sin square p with respect to q, it will be minus 2 sin square p. So minus sin 2 sin square p will be 1 minus cos 2p, or you can say that cos 2p minus 1. Right? So these two values are same, so that means these are same. If these are same, so you will say that, you will say if these are same, so that means this right hand side is the exact differential of some function. If this is the exact differential of some function, so I will say that that is minus of delta f, I say. Okay. Exact differential of some function. So you will say that is equal to some minus of delta f. So that means what was that? हम क्या लेकर चले थे? P tilde into delta q tilde minus P delta q, that is equal to minus of delta f. So what does it mean? That means the given transformation will be canonical. Okay. By using this condition. Similarly, there is a next question. What is over here? You have to show that the transformation, this one, is canonical. Also you have to find out the generating function. Okay. So similarly here you can check t is not involved in the transformation, that means t is fixed. If t is fixed, that means delta of t will be 0. If delta of t will be 0, so I will write down this one. So p is summation pi delta qi and minus h delta t, but delta t is 0, so I will not write it here and that will be there minus delta f. I taken over here c as 1. c को हमने 1 लिया है यहाँ पर, because c is some constant, so I taken c as a 1. Okay, so that means you have to show this thing. To show the given transformation is canonical, you have to show this one. Hold. That means you have to show that that will be equal to minus of delta f. But here are given only the two equations. In terms of p and q, there are only the two equations. Okay, but we write down the condition for n equations. So we will write down only for two equations. So for the p tilde and q tilde, we write down this condition as p tilde into delta q tilde minus of p delta q, that should be equal to minus of delta f. That will be the condition to show the given transformation is canonical. Okay. So to prove this one, I consider the again LHS. When I take the LHS, you can check p tilde delta q tilde minus of p delta q, that will be equal to, you just place the value of delta q, q tilde. So when I place the value of q tilde, that is p tilde delta of, that is q tilde, log of sin p by q minus of p delta q is as it is. Right. P tilde, that will be log of sin p minus of log of q. right? Delta and minus of p delta q. Now you take an inside, that will be derivative of this. So you will take the 1 by sin p into p again, derivative of sin p, that will be cos p into delta of p. Each derivative will be 1 by q into delta q and p delta p as it is, right? So this will be equal to this thing, right? Now you can check that if you place the value for the p tilde. What is p tilde? P tilde is q cot p. I place it over there from the question. Q cot p, when you multiply inside, you will get that q cot square p delta p minus cot p delta q minus p delta q. Okay, so again I rewrite this equation as some term into delta p plus some term into delta q. But this will be the exact differential of some function when partial derivative of this with respect to q and partial derivative of this with respect to p is equal. Okay, again the same case, m dx plus n dy, that case you can consider. So similarly the case is in this form, m delta p plus n delta q. So that means if partial derivative of m with respect to q and partial derivative of n with respect to p, if these are equal, then the given function, that will be the exact differential of some function. Okay, so I will say that इसका partial derivative with respect to q, that should be equal to partial derivative of this with respect to p. So let us check that one. जब इसका हमने partial derivative निकाला, that is cot square p. When we are finding the partial derivative of this with respect to p, that will be minus 1 plus cosecant square p, and cosecant square p minus 1 is cot square p. So that means these values are same. So that means these values are same. If these are same, so that means the equation 2, right hand side, this will be the exact differential of some function, and I call that function is minus of delta f. So I call this exact differential is minus of delta f. So if this is equal to minus of delta f, so I will say that the p tilde into delta q tilde. Okay, that means we got p tilde delta q tilde minus p delta q is equal to minus delta f. Okay, so that means the given transformation is canonical. The given transformation will be canonical, right, by using this condition. Now you have to find out that function. Okay, हमें genetic function find out करना है. So as we saw that is equal to some minus of delta f over this is nothing but this one. Okay, this is equal to minus of delta f. Okay, I write down minus of delta f is equal to q cot square p delta p minus q cot p delta q minus p delta q. Okay, again I rewrite this term over here. That is the same. ये कंडीशन आ गई थी जिससे ये ट्रांसफॉर्मेशन कैनोनिकल हो गया. अब माइनस डेल्टा एफ की वैल्यू हमने लिखी है क्यू कोट स्क्वायर पी डेल्टा पी माइनस कोट पी डेल्टा क्यू माइनस पी डेल्टा क्यू, राइट. और व्हेन यू ट्रांसफर द नेगेटिव साइन, both side multiply them with the minus sign, you will get this one, right. So now you rewrite the terms as I p delta q I have written over there. Now I am adding a subtract in this term, q delta p and q delta p, add and subtract. Now I write down this term cot p into derivative of q is there. So I write down q into derivative of cot p into delta p, I have written over there. Okay, so that means I add and subtract q cosecant square p delta p, subtracted and added, and remaining term is as it is, right. Now you can check what is this one. This is the derivative of p into q, so I write down this one and this term as it is. And what is this term? This is the derivative of q into cot p, so this is the derivative of this one, and remaining term this one over here and this one over here, right. Again in all the terms you can check that this is the delta of p q, you just combine these terms, delta of PQ plus delta of PQ plus delta of Q cot P. I collect this term, and over here in this term, in this one and in this one, Q delta P is common there, so I just write down minus Q delta P. It is 1 minus of cosecant square P plus cot square P, right? 1 minus cosecant square P is minus of cot square P, okay, and plus of cot square P, so that will be cancel out, so that will be 0 into something, that will be 0, and when you combine this term, this is delta of PQ plus Q cot P, okay. So that means we got delta of F will be equal to delta of PQ plus Q cot P, और you can say that function मेरा क्या मिल गया, PQ plus Q cot P. That means F is a function of PQ, which will be PQ plus Q cot P. So I write down this one. Delta F is equal to this one. So that means F will be equal to this one, which is a function of PQ. Okay. Now if you find out the, so I will get the generating function in terms of the PQ. Right. Now if you find out the generating function in terms of the Q and Q tilde, that means I call that function S. S is a function of T, Q, Q tilde, but T is not involved here. So I can say that you have to find out the S, which is a function of Q, Q, Q tilde. Okay. But generating function मेरा क्या है, ये है, तो that means this S will be equal to this one. बस हमें इसे find out करना है in terms of Q and Q tilde. Okay. So you will say that S is nothing but this F, that means this one. So I'll write down S will be equal to this one, PQ plus Q cot P. But हमें S को define करना है Q और Q tilde के terms में. Okay. So that means I will write down the value for P and cot P. I will place the value for this one and this one. So I will do it. So as the given equation, what is the equation is given? Q tilde की value हमें given है log of sin P by Q. So if you find out the value of sin P by Q, that will be nothing but e raised to power Q tilde. Okay. Because the left hand side becomes the power of the base, that is e raised to power Q tilde. Right. Or you can say that sin P will be equal to Q into e raised to power Q tilde. Or P will be equal to sin inverse Q into e raised to power Q tilde. Right. You place the value of this P or value over here. Now you have to find out the value of the cot P also. So what is cot P? Cot P is cos P by sin P. Right. Sin P I know. So by using the sin P you can find out cos P. Cos P will be 1 minus sin square P. Alright. This is 1 minus sin square P. So I write down. This is Q into value of P. I have written over there. So Q into sin inverse of this one plus Q into cos by sin. Cos is 1 minus sin square and sin is this. So that means 1 minus Q into e raised to power Q tilde square and divided by Q into e raised to power Q tilde. Right. So when you got this one, so you can check Q and Q will be cancelled out. So it will be 1 minus Q e raised to power Q tilde square divided by e raised to power Q tilde. So when you take inside the root, that will be e raised to power Q tilde square. That means e raised to power 2Q tilde. Okay. So when you divide individually, you can say that e raised to power minus 2Q tilde minus Q square root sign. Okay. And Q into this one. So that means you will get the function in terms of Q and Q tilde. Okay. So that is the generating function we want. Right. Now there are some properties for the Poisson bracket that we have left before. The Poisson bracket of x into yz, that will be equal to y into Poisson bracket of xz plus z into Poisson bracket of xy. Right, where x, y, z are the function of Hamiltonian variable t, q, i, p, i. So I take this one, x into yz, that will be equal to partial derivative of this first with respect to qj and the second with respect to pj minus first with respect to pj and second with respect to qj. Right, that is the definition for the Poisson bracket. Now that term is as it is, and when you partial derivative of yz, what will be this one? Partial derivative of y into, you just apply the product rule over there. Right, and minus this one, again apply the product rule over there. Right. when you apply the product rule, now you can check that what is this one. Over here when you multiply, that will be y into curl x by curl qj into curl z by curl pj. Is any the other term for the y? That term. So when this will be multiplied with this one, y is common here. So minus partial derivative of x with respect to pj and z with respect to qj. So I collect this term. Y is taken common outside the summation. X with respect to qj, z with respect to pj, minus x with respect to pj and z with respect to qj. Right? Plus z is common there from over here and from here over here. So what is left here? Z is common here and summation x with respect to qj, y with respect to pj, and minus of x with respect to pj, y with respect to qj. Right? Now again by using the definition of the Poisson bracket, you know that this is y as it is and this is the Poisson bracket of x into z, x and z, plus z, this is the Poisson bracket of x and y. Right? So x into x comma yz Poisson bracket, that will be equal to y into Poisson bracket xz plus z into Poisson bracket xy. Now the next one is x into Poisson bracket of y plus z, that will be equal to Poisson bracket of xy plus Poisson bracket of xz. If I consider this one, according to definition, summation j is varying from 1 to n, partial derivative of first with respect to qj, second with respect to pj, minus partial derivative of first with respect to pj of second with respect to qj. Okay, now you take the partial derivative of this bracket, y with respect to pj plus z with respect to pj minus of this one. So when you collect the terms x with respect to qj, y with respect to pj, minus x with respect to pj, y with respect to qj, collect in one summation and the another in second summation. So I collect in this one. Hey, okay, the second summation I collect in this one. So you can check that that is the definition for the Poisson bracket of x and y. This is the Poisson bracket of x and z. Okay, so you will get that Poisson bracket of x into y plus z. You can apply that notation over there, or you can apply in the round bracket also, but you have to show that notation you are using for the Poisson bracket. Now we will find out the Hamilton equation of motion in terms of the Poisson bracket. Okay, suppose that we consider qj and the function h, Hamilton function. So we are finding the Poisson bracket. So when you write down the Poisson bracket definition, suppose that the summation is varying over the I is varying from 1 to n, partial derivative of qj with respect to qi and the second with respect to pi, minus first with respect to pi and second with respect to qi. But we know that all the qj and pi's, all are qi pi are independent one. Okay, so if you are finding the derivative of qj with respect to pi, that is 0. If this is 0, so that means that part removed. If that part is removed, so we are left with only this one. Poisson bracket of qjh, that will be equal to summation curl qj by curl qi into curl h over curl pi. Okay, so what is this one? Whenever you find out the derivative of all the variable with respect to, that means j is also varying and I is also varying. So what it will be? When you are finding the partial derivative of qj with respect to qj, then only it will be 1, otherwise that will be 0. So that means when the I will be equal to j, then this value will give 1, otherwise 0. So I will write down when I is equal to j, so that value is 1, otherwise 0. So you know that this function is known as the canonical delta. I denote this one as delta of ji. This term is denoted as delta of ji. When I and j are equal, then it's give 1, and when not equal, it gives 0. So I write down this value as delta of ji, curl h over curl pi. When I is j, so this will be 1, and when I is j, it will be curl h over curl pj. Okay, so it will be curl h over curl pj, and remaining terms will be 0. So that means that summation will be curl h over curl pj only. Okay, but you know that what is curl h over curl pj? You know that the Hamilton equation qj dot will be equal to curl h over curl pj, right, and pj dot that will be equal to minus curl h over curl qj, right. So what is curl h over curl pj? That will be equal to qj dot, that means dqj over dt, right. So you can get dqj over dt, ये किसके इक्वल मिल गया हमें? पॉइसन ब्रैकेट ऑफ qj एंड h. So you will write down the हैमिल्टन इक्वेशन इन टर्म्स ऑफ द पॉइसन ब्रैकेट, कि qj डॉट हमें पॉइसन ब्रैकेट किस टर्म्स में मिल गया, कि qj डॉट को हम क्या लिख सकते हैं? पॉइसन ब्रैकेट ऑफ qj एंड h, राइट. Similarly we find out the Poisson bracket of pj and h. So what it will be? First का partial derivative with respect to qi and of second with respect to pj pi, minus partial derivative of first with respect to pi and of second with respect to ki, summation I varying from 1 to n. But pj, pi and qi, all pj qj or pi qi all are the independent one, so this partial derivative will be 0. If this is 0, so we will left only this part, so that part will be left. So you know that जब pj का partial derivative with respect to pj निकालोगे तभी 1 आएगा, otherwise this value will be 0. Okay, so that means when this I will be equal to j, only then it will be 1, otherwise 0. When I is equal to j, that will be 1, otherwise 0. So this is delta of ji, so I call this delta of ji, and this will be curl h over curl qi. जब i को मैं j कॉल करूँगा तभी ये 1 बन जाएगा, बाकी सभी जगह 0 आएगा. तो जब i को j पुट करूँगा ये क्या हो जाएगा? कर्ल h ओवर कर्ल qj. सो माइनस ऑफ कर्ल h ओवर कर्ल qj, बाकी सभी जगह 0 है, इसलिए समेशन करके आया आपका माइनस ऑफ कर्ल h ओवर कर्ल qj. ओके, बट बाय अगेन यूजिंग द हैमिल्टन इक्वेशंस, यू नो दैट व्हाट वाज दैट? pj डॉट that was equal to minus of curl h over curl qj. Okay, so this is minus curl h over curl qj, that will be equal to pj dot. pj dot means that will be dpj over dt. So हमें इक्वेशन मिल गई, pj dot किसके इक्वल होगा? pj and h Poisson bracket. So here we got the Hamilton equation in terms of Poisson bracket. पहले आपकी Hamilton equations थी, again let me recall you, पहले आपकी Hamilton equations थी qi dot is equal to minus of curl h over, sorry it will be not minus, qi dot is equal to curl h over curl pi, and pi dot is equal to minus of curl h over curl qi. Okay, but here I define that qi dot is equal to Poisson bracket of qi and h. H is Hamilton function, and pi dot, okay, pi dot will be equal to Poisson bracket of pi and h, right. ये हमने अभी डिफाइन की इक्वेशंस इन टर्म्स ऑफ Poisson bracket. Now if you find out the Poisson bracket of qi with qj is 0 always. How? When you apply this definition for the Poisson bracket, it will be of first partial derivative with respect to qk and of second with respect to pk, and of minus of फर्स्ट विद रिस्पेक्ट टू पी के एंड सेकेंड विद रिस्पेक्ट टू क्यू के. बट ये सभी के सभी आपके इंडिपेंडेंट्स हैं. ओके, दैट मीन्स क्यू जे एंड पी के ऑल आर द इंडिपेंडेंट वन. सो दिस विल बी जीरो एंड दिस विल बी जीरो. इफ दिस बोथ विल बी जीरो, सो दैट मीन्स ऑल द वैल्यू विल बी जीरो. सो दैट टर्म्स विल बी इक्वल टू जीरो. Similarly, if you find out the Poisson bracket of pj with pi with pj, so again I use the definition: partial derivative of first with respect to qk and second with respect to pk minus first with respect to pk, second with respect to qk. So that means it will be given by all these are linearly independent. If these are linearly independent, so that means these terms are 0. So that means all the summation will be 0. So that will be 0, right? Now we are left with only this one. If you find out the Poisson bracket of qi with pj, that will be delta gi. Let me check. Apply the definition for the Poisson bracket: partial derivative of first with respect to qk, second with respect to pk, minus first with respect to pk, second with respect to qk. Okay, but you know that all qi and pj all are the independent one. So ये partial derivative मेरी क्या हो जाएगी 0. So that part will be 0. Only this part is left. But here you can check that जब यहाँ पर मैं k की वैल्यू i लिखूँगा तब ये 1 होगा, ओके, अदरवाइज जीरो। तो इसमें लिख सकता हूँ डेल्टा आई के, और इस जब मैं यहाँ पे जे की वैल्यू के की वैल्यू जे लिखूँगा तभी यहाँ पर ये 1 होगा, अदरवाइज जीरो। इसे लिख दिया डेल्टा जे के, वेयर डेल्टा इज अ कोनिकल डेल्टा। ओके, so that means I put I equal to k equal to I. When I put k equal to I, that will be delta II, delta ji. Okay, but delta II क्या हो जाएगा आपका 1, so that is left only delta ji, right? So this will be Poisson bracket of qi pj, that will be delta of gi always. Okay, so these were the result. The next topic we will discuss in the next class. Thank you very much, students.